Hello, in this video we will do exercise 7, page 14. Calculate the GCT of 22 and 27. To find the GCT, we have to do three methods. We have to decompose 22 into two factors. It is 2 times 11. Do we decompose? Can we decompose the 2? No. The 11? No. So we write the 22 is equal to 2 times 11. Now 27, we can decompose it into 3 times 9. Can we decompose the 3? No. Can we decompose the 9? Yes. It is 3 times 3. And we write down this 3 to be all on the same line. So it is 3 times 3 times 3. So 27 is equal to 3 to the power 3 because we have 3. So it is 3 to the power 3. Now we have to find the GCD. The GCD of 22 and 27 is equal to what? Let's see. Do we have common factors between 22 and 27? Look, we have 2 and 11, and we have a 3. So no common factors. So the GCD is equal to 1. And when the GCD is equal to 1, what can we say about 22 and 27? They are relatively prime. Now let's do exercise 9, page 14. Calculate GCD of 9 and 10. To calculate the GCD, we have to decompose 9 and 10 into factors. So 9 is equal to 3 times 3. Can we decompose the 3? No. So we can say that 9 is equal to 3 to the power 2 because we have 2, 3. Now we can decompose the 10 into 2 times 5. So the 10 is equal to 2 times 5. We can't decompose the 2 and we can't decompose the 5. So 10 is equal to 2 times 5. 2 times 5. Now what is the GCD of 9 and 10? Look, do we have common factors? No. So the GCD of 9 and 10 is equal to 1. So what can we say about 9 and 10? They are relatively prime. Now let's decompose the 14. It is 7 times 2. Can we decompose the 7? No. The 2? No. So we write 14 is equal to 7 times 2. Now the 15, we can decompose it into 3 times 5. Can we decompose the 3 and the 5? No. So 15 is equal to 3 times 5. Now what is the GCD of 15 and 5? 14 and 15. Do we have common factors? Look, we have 7 and 2 and 3 and 5. We don't have common factors between 14 and 15. So the GCD is equal to 1. And in this case, we can say that 14 and 15 are relatively prime. And here we have a rule. Look at 9 and 10. They are what? 10 is next to the 9 and 15 is next to the 14. They called consecutive. So when two consecutive numbers are relatively prime. Why two consecutive numbers are relatively prime? Because the GCD between them will be 1. And we have to remember this rule. Now exercise 10. Are 21 and 16 relatively prime? To know the answer, we first think, are they consecutive numbers? No. If no, so we have to find the GCD between them. 21 is 7 times 3. So we write 21 is equal to 7 times 3. 16 is equal to 4 times 4. Now we can decompose the 4 and the 4 into 2 times 2. Now how many do we have? 1, 2, 3, 4. So 16 is equal to 2 to the power 4. Now what is the GCD of 21 and 16? Look, do we have common factors? We don't have common factors. Look here, 7 and 3, 2. We don't have common factors, so the GCD is equal to 1. So are they relatively prime? Yes, because the GCD is equal to 1. So yes, 16, 21 and 16 are relatively prime. Now let's do exercise 11. Complete without calculation. What is the GCD of 100 and 101? They are what? They are consecutive numbers. They are consecutive numbers. So the GCD is equal to 1 because they are consecutive numbers. Now, what is the GCD of 3 and 9? They are not consecutive numbers, but we know that the 3 is a divisor of 9. Why? Because the 3 times the 3 is equal to 9. So the GCD will be 3 because the 3 is a divisor of 9. Now the GCD of 15 and 45. Do we have a relation between them? Yes, we know that 15 times 3 is equal to 45. So 15 is a divisor of 45. In this case, the GCD will be 15 because 15 is a divisor of 45. Now, the GCD of 27 and 28, do we have relation between them? No, but they are consecutive numbers. So the GCD is equal to 1 because they are consecutive numbers. Thank you.